All right. So today we're going to be discussing humidity. Before we do that, I want to show you this demonstration. So you can see my hand is wet, right? So I've got moisture on my hand. And I'm going to put some moisture on the table, right? There it is. There's some moisture on the table. Now, it's stuck there, but not really stuck there because I can make that moisture go into the air. So my hand's still wet. What I'm going to do is I'm going to spread it out. I'm going to increase the surface area. And if you look at the edge, you can see that slowly some of the water starts to disappear. So you can look at the edge, like right there. You can see it slowly starting to disappear, especially right when I lift my hand up. So if I continue to spread it out, it's not like the water is soaking into the table because these tables are non-absorbent. What's happening is that it is evaporating. So I'll continue to spread it out. And like I said, you can really see it along the edges. So let me spread that. And now this is nearly dry. Okay, so where did that water go? That water went into the air. It evaporated into the air. Can you see the water anymore? No, because evaporated water is completely invisible because it is trapped and stuck in the air. All right, now the air can only hold so much moisture in it. Eventually the air cools, right? How does a cloud form? Do you remember? What are the 3 steps for how a cloud forms? So a cloud forms by warm, moist air rising and expanding and cooling. So the cooling is what causes humidity to turn back from gas into liquid or little droplets of water, right? Condensation. So humidity is focused on the evaporation part of it. So in summer, you may have noticed on some days it's like in the low 80s outside and it feels like it's super hot, right? We're sweaty, like it's just like it's super uncomfortable. Your neck is all sticky, you're laying in bed, you don't have the sheets on you, it's miserable. And then some days it could be in the mid 90s, so like 95 degrees Fahrenheit outside, and it feels just about the same. So this is usually due to humidity. In Las Vegas, sometimes the daily temperature gets up to 110 degrees. And still, people are walking around, sometimes with long pants on and long sleeves. But that's because instead of like New York, where we have really humid air, they have very dry air, right? So if we have very humid air, that means when we sweat, right, perspiration, water comes out of our skin and covers our face. If it's too humid in the air, meaning that if the air is packed with water, the water on our face doesn't easily evaporate into the air. Unlike in Las Vegas, where the air is very dry, there's not much humidity in the air. So when you sweat, that sweat almost immediately evaporates into the air, and that cools you down. So that's what I like to think about for humidity. And we're going to be talking about why we sweat. What is going to be like, why does it cool us down? Or what does it do? Does it actually cool us down? Yes or no? So, humidity. Water vapor gets into the air through evaporation, which is just what you saw there in that demonstration, and transpiration, which is the same thing as evaporation, but from plants. So, major concept. Warm air can hold more moisture or more water than cool air. So if we have warm, moist air that rises, expands, and cools, the humidity increases until a cloud forms. So cooling air increases humidity. Okay? So we've got this thing called a Sling cyclometer. I've got some cyclometers here. They're not as fancy as that one, but these are, or this is, a Sling cyclometer. So what's a Sling cyclometer? It's 2 thermometers. One, a regular thermometer with nothing on it. The other one is a thermometer with a cloth on it. The key here is to wet this cloth. So what I want you to think about, or what I want you to even do, because the kids in class are going to be doing this, you're going to want to wet one hand. Not too wet, just kind of get it covered with water. And right now, if I wet this, so where's my thermometer? So right now, my hand that's wet without moving it is 87 degrees. My hand that's dry is 91. So it's already cool. But what's causing it to cool? Wet hand, dry hand. If I go like this, and now I am really just pushing the air against my hand. Now if I take the temperature of my hand, 83 degrees. So the concept is that we sweat, we get water on our face, not because the water cools us, but because when the water leaves our hand and jumps into the air, it pulls some of our heat with it. It takes some of our latent heat, it's called. So when I did this, I forced the water to evaporate even more, causing my hand to cool down. And that's what a Sling cyclometer does. So we have the two thermometers. We call this the dry bulb because this is just a bulb of glass that is dry. And this bulb here is covered with a wick, it's called. And all we do is get that wick wet. So I'm getting that wick wet. All right. And this measures humidity and can measure dew point. But we got to use a special chart for that. Okay, so there's another Sling cyclometer. Dry bulb, wet bulb. So the dry bulb is just a regular thermometer. So this is telling us the temperature in the room. This is in Celsius, and it is 24 degrees Fahrenheit. Each little mark goes up by 2. So 20, 22, 24 degrees Fahrenheit. Right now, the wet bulb is at 22 degrees Fahrenheit. Okay? But the key is, just like with my hands, I need to sling this cyclometer. I got water in my eyes. I need to sling this cyclometer. So it is called a Sling cyclometer because I am spinning, 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 spinning. Now, this is causing the water on the wet bulb to evaporate, cooling down the thermometer. Just like how when we sweat, we get cooled down. So once I'm done swinging, the dry bulb is now still 24 degrees, but the wet bulb has dropped down to 20 degrees. So the wet bulb is 20 degrees Celsius. The dry bulb is 24 degrees Celsius. This is my humidity chart. So the dry bulb, we said, is 24 degrees Celsius. So there's 24 degrees Celsius. And the wet bulb is 20 degrees Celsius. So what is the difference between the wet bulb and the dry bulb? Remember, difference is subtraction. So if the dry bulb is 24, the wet bulb is 20, what's the difference between those two numbers? 24 minus 20 is a difference of 4. So that's my difference. All I do now is I read across until I reach 4, and I read down, right, just to make sure that I'm, okay, so good. The 24 comes across, the 4 down here comes across. It's 69% humid outside. 69%. So that means the air is not really too humid in this classroom. 69 is, for New York, an average humidity. Now, once the air reaches 100% humidity, so if it was 24 degrees in this classroom, and I spun this, and I spun this, and I spun this, and whoa, it looks like the wet bulb didn't change its temperature. That means no water from this is evaporating into the air. If no water is evaporating into the air, that means the air is completely filled with water. It can't hold any more water vapor. Remember, water vapor is invisible, but if there's nothing evaporating, the air can't hold any more. So we have 100% humidity. That's how I know it's definitely going to rain. At 100% humidity, it definitely rains. Okay? So let's see what the dew point is. All dew point means it's the point where dew forms. It's the temperature where dew forms. What is dew on the grass? It's condensation. So it's the temperature where water condenses or goes from gas in the air as humidity into liquid. So an example of this is when you get out of the shower. On the mirror, right? On the mirror, you can see little droplets of water. That's condensation. And that's because the shower is hot, but the mirror is cold. Once that hot, moist air goes past to the mirror, that air reaches 100% humidity and condensation forms on the glass. So in this classroom, it's 24 degrees and the wet bulb went to 4 degrees. If we want to find the dew point or the temperature where condensation will form, which just means that if the temperature drops to this temperature, the room will become a cloud. 24 degrees and a difference of 4, that gives us a temperature of 18 Celsius. So the idea is, if I cooled this room down from 24 degrees Celsius to 18 degrees Celsius, boom, the entire room would instantly become a cloud. Just a, like, fog, okay? All right, so let's try some of this out. So if I have a dry bulb of 12 degrees Celsius, or a temperature of 12 degrees Celsius, air temperature of 12 degrees Celsius, and a wet bulb of 9 degrees Celsius, what would the relative humidity be? So if we go back to our chart, relative humidity, what do we need? We need a wet bulb and a dry bulb temperature. In this case, they said the dry bulb temperature was 12, right? The wet bulb temperature was 9. Do I look at 9 here? No. This is not saying wet bulb temperature. This is saying difference between wet bulb and dry bulb temperature, or the change between those two. So if the dry bulb is 12 and the wet bulb is 9, what's the difference between $12 and $9? What's the difference between 12 Celsius and 9 Celsius? What's the difference between a 12-year-old and a 9-year-old? It's 3, right? 12 minus 9 is 3. So here's my dry bulb temperature, 12 Celsius, and my difference is 3 here. So all I do is read across, right? Read down, and I make sure, okay, I'm on 12, and I'm on 3, so that means that humidity would be 67%. 67%. All right? So that's the main idea for relative humidity and dew point.